Good morning, Jan.
Michael, good morning. How are
Good to see
you?
you, sir. Very good. Very good indeed. Yeah, I do need to end a little bit early today. Make sure that I get into the office to greet a new employee,
Okay.
get him started on maintaining our internal application, which is built on Jinaga. So
Ah,
yeah, I have to teach him the system very quickly.
oh, you should tell him to follow these sessions.
Yes, indeed.
Hmm? You tell me when you have to go. Huh?
Okay.
If it's time, you say, Jan, stop. No, but sure, do that. Oh, because we have a lot to talk about. I saw you made a lot of progress on the database schema
Mhm.
and on the way we should insert it. And I'm
Yes.
struggling, and I'm struggling with JavaScript and TypeScript again.
Oh my goodness.
No, this weekend I thought let's uh, let's set up Jinaga again
Hmm.
so that I can debug through it to see what is really happening. Because when I'm programming it in .NET, the way you do it in Jinaga.JS is very nice as a sample.
Hmm.
But to make sure that I understand what is really happening in JavaScript and TypeScript, I like to go through it and see the values.
Right. Yeah.
And then I got I got stuck, and yeah, I think I spent most of the day yesterday on it. I spent the whole morning on it, and some of the things are going better, but still not the way it should be.
Mm. Yeah. JavaScript can be pretty challenging to
Mm,
debug, especially once you put a few extra layers in there. So we've got the TypeScript compiler, and we've got Webpack
mm,
minification and bundling, and then there's the server side being different from what's happening in the browser,
yeah,
and so yeah, different ways to debug each one of those.
yeah. It was, and for me also, it was a while ago. So to refresh my memory,
Hmm.
uh, it took some time, and then I was confused about the processes,
Hmm.
and I thought, okay, let's debug that in the browser. But the server is running on the server in its process. It just declined that connects to an HTTP endpoint.
Right.
So how can I debug it in a browser? So then I went back to VS Code.
Hmm.
Um, do you want to have a look at your documentation first, or do we attack the?
Let's go ahead and start with the debugging stuff. See if we can make any progress
Okay,
there.
then, because it's really blocking me. Um, is that readable or not? I made the screen a little bit smaller here.
Yes, I can read that.
Okay. So I have two instances of Visual Studio.
Hmm.
I have Visual Studio Code. I have here on the right Jinaga.JS,
Hmm.
and on the left I have the shared list application.
Okay.
Yeah, that was the one I understood a little bit, so that was a good beginning. Now, one thing, I upgraded my NPN version from 6 something to 7 because the package JSON lock
Oh yes.
changed from 1 to 2,
Yes.
and that means it was rewriting my package JSON lock all the time.
Hmm.
So that problem has been solved. Then Jinaga.js was having version, what was it, 2.5.6 was your latest,
Hmm.
but shared list was using 2.5.3. I don't know yet what changed
Hmm.
in Jinaga, but the handler, if you use app.use and it needs the path and then the Jinaga handler, and apparently app.use is looking for an application there and not another handler. So it gave me a type error.
Okay.
So by going back to 2.5.3, that's also gone. So now I can build the shared list application in the debugger. Let me show you. So the Jinaga, I just minimize that one. Here we have shared list. I go to the debugger. I have here this launch.json. So here I have a breakpoint. I say, okay, continue. There I have another breakpoint, configure Jinaga. I say continue. If I take my browser here, see that is working. That is fine. So the application works. But in the router.ts here, so here is creating that handler. I have two breakpoints here, and it gives me unbound breakpoint. And the question is, why is that? So these files, they come from, if I go to in the node modules, Jinaga here, yeah, the HTTP. Just to be sure, we have the linked directory. I added a file in the original Jinaga local application. So I see that file, so I'm sure that I'm having the correct, and if I go to router here, set a breakpoint, but now I didn't do npm install and then the local file. I did npm link.
Okay. Yeah, I'm trying to remember what problems I had with npm link. But yeah, I've just used the local file myself. I think it might have just been an old WSL issue that might have been cleared up since then. So yeah, I'm not convinced that that's the cause of the issue. Okay, so yeah, so we are seeing that we've got the correct file structure here. So in order for it to see the mapping between this TypeScript and what actually gets executed, it needs the mapping file, and it runs that out of dist. And so we can see Jinaga.js.map and index.js.map. So both of those are there.
These ones, yeah.
Yeah. So index is the server side, and Jinaga.js is the client side. Just two different builds from the same source code, taking in different subsets. So
what else was there? There was also something. Wait, where did I write it? So source map, I set it to true in the compiler options in Jinaga. So that's probably the reason why I have these map files here.
Yes.
But then there was also something that I found that, what was it here? To launch.config, you have to add runtime args is preserve symlinks. So if I go here to my launch, I've added this one.
I'm not familiar with that.
And I'm not too sure about this launch.json. Why is giving me PWA node? Which process do I have to choose? I just choose node and it was working, but it might be wrong.
Yeah. Okay. So starting with the program, so I can see that. So this is your server.js. So
You want me to share to make a share on VS Code?
yeah. Let's do that.
It
And
might
then
make it easier
yeah, I can navigate through it.
if I share. Yes. Clipboards. Find it link to the clipboards. Okay. I will paste it. General channel. Okay. To the general channel now.
All right. Following that. And getting signed in. And joining the session. Okay, it didn't let me do that through the browser for some reason. Let me hit that again and see if I can join through Visual Studio Code. Oh, it looks like it, once I said no, use the browser, it kept that. So let me copy the link and join a live share session in VS Code.
It was being complicated, this sharing.
Yes, indeed. Okay, making sure that everything is connected. Still not seeing it. Let me try one more time. Live share, join collaboration session. And I'm not even seeing my live share. All right. Let me try one more window. Okay, I'm thinking that my live share extension. Okay, no, it's working.
I don't see participants here.
It looks like, restricted mode is intended for safe browsing. Okay, trust.
Yeah, join the
Okay.
collaboration. Are you in restricted mode? Okay.
Yeah, it looks like I am joined. And in fact,
Yeah.
I can even see shared list in the browser. So that part's working too. Okay.
And the problem was the extension was not active, or?
I'm not really certain. I just started a new instance of VS Code and it started working. So just something you have to fiddle with. Okay. All right. So yeah, starting here, we've got the program is dist server server.js. So we can see that here is so I've got the source. I'm not seeing the dist folder, but clearly it must be there because
Yeah.
Yeah, it's saying that it is. It's running. And so if I take a look at the scripts, so build uses Webpack and um,
Mm-hmm.
TSC in order to build that. So the Webpack config says that my input is going to start at main.tsx, and then we're going to do some compilation. These are the modules we're going to look for. Then output is name content hash.js in the dist folder. I think what might be happening is that it's able to map the JavaScript that it builds, and so there's probably a map file in the dist folder, which unfortunately I cannot see, that that has the mapping for server dash and then a hash.js. If I take a look at the
for server.js and for routes.js.
okay, good. Yeah, so okay, wait a minute. I'm sorry. I confused myself. So the Webpack file is just for the client side. So that's main.tsx. So that would be main.js or main-hash.js. And that ends up in the scripts folder inside of dist. So that one is not the one that we are focused on. We're using TSC and the project source server in order to compile the server side. And so tsconfig on the server, that is where you added source map true. Yep. So what I am thinking is the TypeScript compiler is creating a source map for the source that it itself is compiling, but it's not compiling the TypeScript for Jinaga.JS. Instead, it's using the already compiled Jinaga.JS, the minified package that is distributed.
Yeah.
And so because of that, you can't set a breakpoint inside of Jinaga.js. You can only set a breakpoint inside of your own code. So how to change that? I'm not sure.
But when I built the Jinaga.js itself, which one is it? This one. So there in my tsconfig, I also have source map equal to true. I'm not sure whether you can see that on the stream.
Oh, on the stream. Okay.
Yeah.
Yeah, I was trying to follow you on live share. Okay, stream is here. There. Okay.
So there we are in Jinaga.js.
Right, yeah. So Jinaga.js is outputting the source map. But the thing is, I don't think that the shared list application is using the Jinaga.js source map. It's creating a source map of its own for its own TypeScript source code. But I don't know how to tell TypeScript, or even if you can tell TypeScript, to use the source map from one of its libraries that it finds in Node modules, or in this case in a symlink. I don't know if you can do that one layer of indirection there.
Because if we go back now, I'm in shared list. So actually, if we go to the so in the Node modules, yeah. I go here to Jinaga, Jinaga here.
Mm-hmm.
So here we have the
Yeah.
dist folder of Jinaga.
Mm-hmm. Yeah, and it has the source maps in it.
Yeah, and that has the source maps in
Yeah.
it.
Yeah, I think the runtime is only using the first source map that it sees, and the first one that it sees is shared list. So um, that layer of indirection that I'm talking about is that we want some mechanism. I don't even know if this mechanism exists. Some mechanism to take the source map from one of our dependencies and include that within our own source map.
Yeah.
If that's possible, I don't know how to do that.
And we cannot make it so that because he has the source code here as well,
Right, yeah.
that he compiles, that he builds it using the source code.
Mm-hmm. Yeah, so all the information is available if the tool
Yeah.
is actually um, set up to do that. But I just don't know if it is. I don't know if the TypeScript compiler works that way, and I don't know if Webpack works that well. Webpack's out of the picture. We're just talking about the TypeScript compiler. Yeah, I don't know if the TypeScript compiler or the debugger is set up to follow that layer of indirection, even though it has all the information if it could.
And then what's the difference with if you try to test Jinaga,
Hmm.
making a local copy?
Right. Oh, okay. Yeah. So um, the type of testing that I will often do um, is not debug step through, but instead do the add the logging statements and that kind of thing until I figure out what's going on, and then I'm able to, because I've done the you know, added the library directly rather than through NuGet or npm package. Then I'm just able to make the change that I think needs to be made, compile it, and then test it immediately.
You build again, yeah,
Yeah,
and that's working, and that's
yeah,
working.
yeah, yeah. So
It's
I mean,
only the
it's one small advantage, but it's not the full
okay.
you know, set breakpoint experience.
Never mind. Then there
Yeah,
is no easy solution. Then
yeah.
I will,
I mean,
I will, no, I will continue to search for it.
okay. There might be an easy solution. I just haven't been able to find it myself, um, and I usually
Yes,
just live without it.
but it would surprise me if it would not be possible.
Hmm.
Um, Another possible. Yeah, copy everything in the source code in the local source code.
I have done that
That
on
that
occasion.
yeah.
Yeah, actually, kind of early in the project, I had
Mm,
a sample application within the Jinaga.JS source code itself, so I could just run it. I can step through it because it was all compiled locally. Everything was packaged into just the one application. Um, and then once it got to the point where I wanted to start publishing the package, that's where I started separating that out.
yeah. No, I will. You give me a good direction that the map
Okay.
source needs some some second link of so I can look for that.
Yep. Yeah. Wish it were easier.
Yeah, look, sometimes it's like that. Um, then I continued a little bit on the database itself.
Mm-hmm.
Um, there, yeah, I'll just show it to you. It's not much. How was it here? Screen. Stop sharing. Streaming. Yeah, that one, and then screen. Go to Visual Studio Live. Okay, that's Visual Studio. So go to that connection factory. So for the moment, I just forgot about the transaction.
Mm-hmm.
But my conclusion was actually that the SQL-net library, that we might not need it.
Right, I think so.
Because it's actually an ORM layer, and there is this raw layer between underlying it, and then SQLite. So you have the original SQLite layer, then you have this raw library, which translates the C calls to C# calls.
Mm-hmm.
And on top of that, you have that SQL-net .pcl. But that's just an ORM layer,
Mm-hmm.
which we don't actually need. For example, so if we do this connection, before I do that callback, I go and check whether we have the database. And I create the database. And so I just do a SQL statement for create table for the indexes, and then I call that that async connection that I have with execute async, and that works perfectly.
Excellent.
So the moment that we go and save, go and select, go and insert, we can just use standard SQL. And all the layers in between we don't need, I think.
Right, yeah, yeah.
So
Excellent, yeah. I had to remind myself real quick when you were showing this, because I had that immediate reaction. This is all client-side database code. If somebody was creating a database within their server-side application, I would say, whoa, stop. The server-side application should have far fewer permissions than something that is actually doing the database migration and deployment. But this is all client-side, and we're not doing a two-step deployment and then run. It's the user ran the application.
Yeah. So and this works fine. The table is created, but these are just the two tables like it was in Jinaga.JS. So the fact table and the edge table and the fact table. But on the client side, you also would implement the full schema like you designed for performance?
Yes, yeah. In fact, I'm currently seeing some performance problems with Jinaga.js. So I've been using Jinaga.js for an internal application that we've been running for years. It has a lot of data in it now, and as you may expect, that data doesn't go anywhere. But it's using the period pattern so that it's only selecting certain subsets of the data. But nevertheless, there's enough activity in the application now that when I switched from a virtual machine running Postgres to a managed Postgres provider, the managed provider was just slow enough that it started a timeout on the load calls, which is the asynchronous, the recursive walk through the edge table in order to find all your predecessors and run the transitive closure.
That's why you define that ancestor table.
Right, exactly.
Okay.
Yeah. So yeah, I think I might find myself implementing the ancestor table in Jinaga.js very soon. And as I do, I'm also going to take all of these string joins. So it's in order to go from edge to edge, it's joining on successor type and successor hash. So those are two string joins, it's stringing a whole bunch of those together. And then the role is in the where clause, so it's doing a whole bunch of filters based on strings as well. So replace all those with integers, and that should give us quite a bit.
Yeah.
Yep. Yeah, and I think that performance improvement, I mean, it's going to be important for the server because the server has a lot of data, but I think it's also important for the client because we want to limit the amount of memory that we're using on the client as well as the battery usage, and we know that we're running on an underpowered machine.
Might even be more important for the clients than for the server.
Yeah.
Because the server is using Q, so he
Yeah.
can do all day, while the client is just a very small machine.
Yes. Yep.
Good.
So it adds some complexity, but I think ultimately it's going to be worth it.
No, but it's nice to see that you're running into these problems in a real application.
Yes, indeed.
So that means that it is well used. Then, when you told me that you made some updates in the documentation, I went to GitHub. I said, no, there is nothing changed until I went to the SQL branch.
Yes.
Okay. Because on the database schema, I had some questions. So for the fact type, so fact type ID is a primary key representing the fact type locally. Is that the reason why you copy the fact type table in the signature table if in the key store, if these are two different keys, two different stores? So you have the fact store and you have the key store.
Oh,
the
right.
key store.
Yes. Yes, that is correct. So yeah, let me get to that so that I can follow along. Yeah, so in the
perhaps you can put it on in the stream also.
Yeah.
Stop this one. Oh, you want me to show it?
No, I'll go ahead and show that. All right, so we should have it showing now. Okay. So we've got the schema. So yeah.
Yeah.
Yeah. So we've got the fact type, role, fact, edge, and ancestor, and those are all part of the fact store. And then the user and the signature, as you're saying, part of the. Wait a minute.
E-store.
You know what? I think I might have. Yeah, that is incorrect. You just actually found a mistake. The user is in the key store, so I can log in as a user. So using a provider, maybe it's Azure Active Directory, and so we've got that provider name, and then we've got the user identifier that Azure Active Directory gives you, which in that case would be a GUID, and then you can look up the private key and the public key for that user. So that is the entire job of the key store. Signature, actually, I got this incorrect here. Signature is part of the fact store. So you can save the signature of a fact without knowing the public or private key.
Okay.
Yeah. So let me move that up there. Yeah. And then this business about the fact type ID and the key store being separated, that's incorrect because the signature is not part of the key store. So take out those things. The user ID is a foreign key to the user table. Wait a minute. Now I just confused myself here. Okay. So actually what I'm seeing here is a mistake in the schema because so far I've not separated the fact store from the key store. So now I have this foreign key to user ID, which I shouldn't actually have in the fact store. And the reason for that is that when I validate the signature, I need to look up the public key, but I should be able to look up your public key without knowing what your private key is. So your private key should only be stored in your key store.
Mm-hmm.
So that could be on the device if you want to be really strict about it, but that's very inconvenient because that means you could only use that one device with that identity. So more convenient, slightly less secure, is that you have a key store that you trust that's off of your device, just one hop away. And so when you sign in, you present a token to that key store, and then it's able to sign documents on your behalf. But that information should never spread out beyond. And so ideally I want that to be in a separate process, separate database from distribution. So what we really need is a different
Split the user table.
Yeah. So this doesn't know about the provider or the identity or the private key. So I mean, yeah, giving it a yeah, this is the version in the fact store, and this is the version that's in the key store. So what I really want to do then is give them different names. So the IDs and the foreign keys will change names as well in order to make it a lot less confusing. So it's not that you have a user table in two different databases that just have different columns, but you can see these are two completely different tables. They're used for different purposes. This one is just to look up a public key, and that one is to so actually, yeah, this one, the alternate key is public key.
Why not call that first one the public key table instead of the user table?
There we go. Yep. So yeah, we can only we use that just as a foreign key there. Yeah. It's a little bit strange to read, but yeah. And then oh, where is my? Oh, I thought I had. Maybe it's only on the Mac that I've got a plugin that cleans that up for me. But okay, I'll do it the hard way. Okay, so this is the public key that we have in this other table. Okay, so that's the public key that was used to sign the fact.
Yeah.
Okay. All right, now we can be really explicit about the division. So, in fact, I'll say this is the fact store, and bump these down a degree. And then this is, oh yeah, that's also in the fact store. And this is where the key store begins. Okay, so the key store is just that one table. Uh-huh.
Yeah.
Just the user table. So in fact, it doesn't need a primary key because we're only looking up by provider and user identifier a key pair. That's all we're doing. So yeah, we'll just get rid of that. Excellent. Yeah, thank you.
But then on top, 7 tables has to be 8 tables then?
Yes.
Yeah, all the way on top. And then there is somewhere the last 2 tables make up the key store. That's just above ancestor.
Hmm.
That was in, yeah, there.
Yeah. Okay. Oop. I'll just move that whole thing down here and then,
Last table.
yeah. Okay.
Okay.
Very nice. Yeah, so for the work that you're doing right now, you can ignore the user table altogether, because the client side should be just relying upon an external key store. Otherwise, you wouldn't be able to use this identity on anything other than this client.
Okay.
Maybe in the future that will be an option because some applications you might actually want that to be the case, that this is a trust no one type of an application. So I generate the private key here and never leaves this machine. And so I can, if you see a signature out there in the world, it really came from this device.
But if the user loses his device or it breaks down, then we have a problem.
Yep.
So.
Yep. Which is why we don't want it to be the default. It's going to be, even though it's secure, that's really inconvenient.
Yeah, but it can be so secure that nothing is working anymore. And that's not the purpose. In the fact table, Michael, you write the fact type ID is a foreign key to the fact type table, and the alternate key is composed of the fact type ID and the hash. Why not only the hash? Is it to limit collision chances?
It's because the fact type is not included in that canonicalized fact. So we take the fields and the predecessors, write them in JSON, and so now that's just one column. In the previous iteration, it was 2 separate columns, and never could figure out why I did that in the first place. It's like, no, I have to put them together anyway. So, but that data does not include the fact type, so that means it doesn't depend upon the fact type. This hash, if you happen to have 2 different fact types that have the same set of fields, then they would, if you actually used the same fields, they would compute the same hash, even though they're 2 different types. Like, for example, this is a top level type, and you're using a natural key in order to represent that thing. So a company and a website, 2 top level facts, and so you're using the website's domain, improving.com, and then you're also using the company's, you might have company name as the only field in there, and you're using that as a natural key. And so if you say improving.com is the name of the company, in this case it's not, but in some cases the name of the company is the same as the domain, then those 2 facts would actually have the same hash. And so, so you have to have the fact type to differentiate them.
Because the fact type is not part of the hash calculation.
Right.
Okay. I forgot about that. Actually, theoretically, the predecessor hashes we don't really need them in the fact table because we can calculate them from the edge table, no?
So you do need them in this data for two reasons. One is that this is used in order to compute the hash, and so the set of predecessors is part of the identity of the object, and so it has to be included in that hash. But the second reason is that with just the edge table, you can't tell if you have a collection of predecessors that only happens to have one instance versus a truly singular predecessor. And this, when you're talking in C# and you have a strong type, you can actually just look at the type and figure out, was it declared with an array or a single value. But so yeah, that comes from the JavaScript version, in which you don't have that type information. Even if you coded it up in TypeScript, that information has been erased by the time it gets to runtime. So the structure of that JSON inside of data looks different for an array than for a single value. And so yeah, for complete compatibility, that same structure is used even on the C# side.
Okay. What else did I have here? Yeah. Okay, in the signature, you also have the fact type ID. And why not just use their fact ID instead of fact type ID?
That is a... You're right, that is a mistake. Yeah, so when I was translating from the completely flat structure that's in Jinaga.JS to the one that uses the foreign keys, I missed that. So
Yeah, but
that
the
should
fact
be...
type ID and the hash together determine a fact. So it will work if you have fact type ID there.
It will. Yeah, but this is easier. This is simpler.
Yeah.
So we can go ahead and take advantage of that fact ID. So the alternate key is not the fact type ID and hash and user ID. It's the fact ID and user ID. But it's not user ID anymore. It's public key ID. And Oxford comma. All right. Public key is foreign key, and the alternate key is the fact ID and the public key ID. And now we're just using that foreign key. So we've got direct access to the hash right there. Yep. Which, yeah, actually that hash isn't what's signed. The signature is a signature of the data. So it's not just raw. Take the hash, sign the hash. That's one extra hash operation. So yeah, it does an HMAC SHA-512 or I forget which one I used. But yeah, it does a HMAC over this data. So it's not incurring any extra hashes that it doesn't need to, which would actually weaken the signature a bit.
Okay.
Yep. At any rate, yep. Good call out.
And then you still have the document about safe effect, but
yes, but we're not going to have time to get into that.
I was thinking that. Okay, Michael. Then next week you will be there.
Yes, indeed. Next week, we will we'll actually go over the steps to save a fact,
Mm-hmm.
and then maybe by then I will have some of this implemented in Jinaga.JS as well, and so we can see the SQLite versus the Postgres.
You will win. That's certainly.
Yeah. At least
Well,
the foreign keys in the ancestor table. What I
mm,
also really need to do is update the query generator so that it can handle full pipelines, whereas right now it can only handle a linear pipeline, so no projections. Um, so that's going to be a challenge for another day. Won't have that done
okay.
for next week, that's for sure.
Michael, thank you very much. And see you next week then.
Indeed. Thank you so much, Jan.
Okay. Bye bye.
Bye.